Hello everyone, in this video we will learn Black Widow optimization algorithm step by step using different examples. Here we have list of topics covered in this video. First we will start with what is this algorithm all about, algorithm inspiration, its working and different mathematical models used in this algorithm, and step by step we will learn how this algorithm is working. So first we will start with algorithm inspiration because Black Widow optimization algorithm is inspired by the unique behavior of black widow spiders in real life. So first we will discuss black widow spider behavior in real life so that we can easily understand how this algorithm is working. Because different mathematical models used in this algorithm, they are designed based on black widow behavior in real life. So first we will discuss real life behavior of black widow spider. Then we will discuss step by step how this algorithm is working. Now first we will discuss about black widow spiders. About black widow, they play a very important role in maintaining the balance of ecosystem because they feed on insects and control pest population, and they often build irregular sticky webs close to the ground to trap their target. And after injecting the prey with venom, spider consume the liquefied tissues, and their diet includes flies, mosquitoes, beetles, and other. And they are found in warm climates in North or South America, Australia, Africa, and parts of Europe. Now we will discuss about their physical structure. They prefer to live in dark areas like untouched area of garage, rocks, cracks, or storage areas. Female black widows are shiny black with a visible red hourglass mark. You can see here this eye-catching red hourglass marking. This mark acts as a warning to the potential predator. And about male, you can see they are smaller and less noticeable brownish color with lighter marking. And black widow egg sac can contain hundreds of eggs, and about their lifespan they can live up to 3 years in captivity but shorter lifetime in wild. Now you can see here this spider named as black widow because male often face the risk of being consumed during or after mating. During or after mating, female often eat the male. She then place her eggs in the safe sac. When baby spider hatch, they start eating their siblings, and if they stay on their mother's back for a longer time, the stronger one might eat the weaker one and even their mother. Done. So this algorithm is basically inspired by the unique behavior of black widow spider. This algorithm mimics the biological behavior to perform global optimization over search space. In real life, black widow spiders spend their most of time on their webs for feeding, mating, and hatching eggs. Female spider release a special chemical, that is pheromone, to attract male spiders, and when any male spider reaches her web, then her web become less attractive to other male spiders. And during or after mating, female spider often eat the male. So this behavior is simulated in this algorithm. To find out optimal solution, now step by step we will discuss this algorithm working. So here we will initialize all the important parameters like population size, total number of variables, then we have different settings for input, percent of crossover, then number of selected parents, then we have percentage of mutation, number of mutant. So first we will initialize the population of black widow spider. In black widow optimization algorithm, each potential solution to the problem is called a widow. So here every widow represents a black widow spider. So for any optimization problem with n variables, we will represent each widow as 1 into number of variables in an array. That is the solution of the problem that we are trying to solve. Here you can see this array. We have x1, x2 up to number of variables. So we will initialize the position for each black widow. Done. And we will perform fitness evaluation for each to check how good that solution is for solving respective problem. So we will apply the objective function on their initial position to calculate the fitness score. So initially we will randomly generate the initial population of spiders using a candidate widow matrix. You can see here we have rows and columns. In rows we have the population, and in column we have the total number of variables. Now suppose we have population size 5 and total variables we have 4. Means we have 4 variable per widow. Now you can see the widow matrix. So here we have 5 search agent as a window, and you can see dimension means total number of design variable we have 4. For example, for the first window we have 0.8432, second variable we have 0.1449, third variable 0.7761, and the fourth variable we have 0.3407. So this is row 1. Like that we have row 2, row 3, row 4, and for the fifth window we have row 5. So here each row represent a window, that is the solution, and each column represent a variable. Done. Now step 2. Now based on pre-creating rate, we will calculate the number of reproduction NR. So as in real life, spider produce many eggs but only the stronger ones survive. Similarly, in this algorithm, new solutions are created during mating, and each pair of widow will mates on their own, just like in nature. So to simulate this behavior, now in order to reproduce, they will use a random number alpha. It is used along with the parents x1, x2 to produce two offsprings y1 and y2. So using this equation, we will perform this. Y1 first offspring is equal to alpha into x1, that is first parent, plus 1 minus alpha, that is our random number. Then we have second parent x2. Like that we have y2 is equal to alpha into x2 plus 1 minus alpha into x1. And to ensure that the random pair are unique, this process is repeated for number of variable divided by 2. Now suppose we have 4 variable divided by 2, that is 4 by 2 we have 2, that is half the number of variables. So this will repeat 2 times. Now after creating offsprings, they are combined with their mother, that is the original widow. Done. So for all widow in the population, we will repeat this process. Suppose this is original widow matrix. You can see population size. Now suppose offsprings are created through mating. Now we will combine the population. Here we have original widow plus the offsprings. After this, we will perform the fitness evaluation and selection. After fitness evaluation, we will sort the population based on their fitness value in descending order, and we will put the best solution at the top. And here the solutions are sorted to ensure that the best performing one are at the top and ready for the next step, like selection and cannibalism. The next we have cannibalism. So cannibalism in black widow optimization is model based on real life behavior of black widow, and this occurred in 3 stages. Like first we have sexual cannibalism. In nature, female widow eat their mates during or after mating. So this is simulated in black widow optimization algorithm using fitness values. So using fitness values, we will determine which widow represents male and which represents female. So here weaker individuals with birth fitness value are male, because in real life male is killed by the female. So here we will remove the bad solution. So here male is removed after producing offspring. So we will remove the birth solution. Done. Second stage we have sibling cannibalism. In real life, strong spiderlings eat weaker one to survive. So in this algorithm, after offsprings are generated, a cannibalism rate CR is used to determine how many individuals will survive. Now suppose we have cannibalism rate 0.5, means only top 50% of individuals are kept and rest are removed. So this step is done to ensure that only stronger offsprings contribute to the next generation, and this fraction of offspring population will survive based on cannibalism rate selected by their fitness score. In the third stage, we have maternal cannibalism. So as we discussed earlier, in real life sometime baby spider eat their mother for their survival. So in this algorithm, we will check the fitness score. So after fitness evaluation, if the offspring outperform the parent like mother, then we will replace the mother with the offspring in the current population. This is done to ensure that the population keep improving over generation. Offspring with better fitness values are replaced with the bigger parents. For example, suppose we have total widow in this population 5, and after mating we have 10 offspring generated, 2 offspring per parent pair. Okay. Now total population after mating we have 15, 5 parent plus 10 we have offsprings. Now suppose we have cannibalism rate CR value 0.5. It means only the 50% of population will survive. 50 divided by 2 we have 7.5, and we can round up this value as 7. Now let's try to understand this using a small example. First, we will combine the fitness value of parent and offspring into a single array. Second, we will sort the population based on their fitness score in ascending order or in the descending order, depend on you whether you're doing minimization or maximization. So based on this, we will sort the population. After this, we will determine the survivors based on CR value, that is the CR rate. So here we have CR into, we have total population individuals, 0.5 into 15, we have 7.5, that is rounded to 7 individuals survive. After this, we will update new population. So now survivor become new population for the next generation, means this is population 2. Done. So here you can see we have parent fitness value 12, 18, 15, 10, 14. Done. Now suppose the offspring's fitness value we have 13, 9, 11 up to so on, and we have parent fitness value. Now we will combine the population. So here you can see 12, 18, 15 up to 16. Suppose we are doing the minimization. Now we will sort the population. After this, we will set the CR value, suppose 0.5. 0.5, it means rounded to 7 individuals. It means we have now 7 individual survivors. So now first 7, 8, 9, 10, 10, 11, 11, 12, 12. Done. After this, we have next step. After this, we'll perform mutation, and based on the mutation rate, we will calculate the number of mutation children. So mutation in this algorithm introduce diversity into population by alerting individuals. So first we will randomly select individuals for mutation. Suppose mutation rate we have 10%. So this is done to determine the number of individuals to be mutated. We have mute pop is equal to population size into mutation rate. Done. After this, we will apply the mutation. So for each selected individual, that is BWO, we will randomly select 2 element position in the array, that is our solution. And after selection, we will swap the values of the selected element. Then we will update population, replace the original individual with the mutated one in the population. For example, we have initial BWO population. You can see this array, and we have total 5 window. Suppose mutation rate we have 20%. To mute population we have 5 into 0.2, that is 1, means 1 individual will be mutated. Now we will perform the selection. Suppose we randomly selected third window for the mutation. Now we will apply the mutation to this third window. So original window array we have 9, 2, 1, 5, and from this array now we will randomly select 2 position. Now suppose we selected position 0 and 2. Now swap these values at the position. So we swap 9 with 1, 9 and 1. So after swap mutated array for this window we have 1, 2, 9, 6. So now here we have updated population. You can see for 5 window. So mutation is done to ensure the diversity and prevent the algorithm from getting stuck in the local optima. Done. Now we will save the new one into population 3. Done. After this we will update. So here we will update the population by combining second population with the third population. Done. So in Black Widow optimization algorithm, mutation randomly swap element in the window array and create new combination of solution and lead the solution to explore region of the search space that are untouched. Now we have the convergence. So in this algorithm, convergence ensure that the algorithm will stop once the optimal solution is found. So after this, we will update the population and return the best solution. So we will return the best solution in the population. So if you are doing the minimization, return the minimum value. So here first we initialize the population for the black widow spider. Then based on their procreating rate, we will calculate the number of reproduction. Then we will select the best solution in the population, then save them in the population 1. After this, we will perform procreating and cannibalism. Then we have mutation, and after mutation we will update the population and return the best solution. So that's all about this video. If you have any questions, you can comment below, and thanks for watching this video.